So everyone says ultra-processed food is poison. I say it. In fact, it is poison. It doesn't have to be. There are 3 precepts and 4 strategies to being able to alter ultra-processed food to make it metabolically healthy. Any food that does those 3 is healthy by definition. Any food that does none of those 3 is poison by definition. The problem with ultra-processed food is it's all emulsified. Those emulsifiers are detergents. They are the same stuff you put in your clothes washer. So what happens if you swallow Tide, emergency room physician? You burn a hole in your intestine is what you do. Well, in fact, that's exactly what's happening. We see the irritable bowel syndrome, the inflammatory bowel disease, the leaky gut, all related to these changes in intestinal inflammation driven by the components of ultra-processed food. So we have to undo that. The question is, can you? And the answer is, yeah, actually, you can.
A few weeks ago, I had the opportunity to interview Dr. Robert Lustig. He's a pediatric neuroendocrinologist. He's a food scientist and food activist. He focuses on the public health problems of obesity and metabolic health. Today, we're showing you that interview. We discuss a lot of topics, and the main one being the foods that are slowly killing you.
Speaking of all the different ways of approaching this, public health awareness, you've been tireless on social media. Now you've recently mentioned that you're helping, or you're looking to help from a business perspective with Munch. Now,
yeah, I'm doing a bunch of things, and we'll talk about Munch in a minute. But I'm also helping the food industry directly. I'm not taking money for it, but I'm actually working with food companies to alter their products.
Tell us about that.
So there is a company in Kuwait, Middle East. It's called Kuwaiti Danish Dairy, or KDD. They are like the Nestle of the Middle East. And they made all sorts of junk. And Kuwait has an 18% diabetes rate and an 80% obesity rate. During the pandemic, I got a phone call from the chief business officer of KDD asking me, would I be interested in helping them turn themselves into a metabolically healthy company? I said, whoa, well, now there's something. They said, we'll put the money up. You know, we are a privately held company. Because they don't have Wall Street quarterly reports and they don't have stockholders, they can take the long view. They can do the right thing and they can absorb the cost. And so I put together a scientific advisory team of 5 people. And for the last 3 years, working tirelessly, we developed a protocol, a set of precepts to be able to turn ultra-processed food into healthy food. So everyone says ultra-processed food is poison. I say it. In fact, it is poison. It doesn't have to be. There are 3 precepts and 4 strategies to being able to alter ultra-processed food to make it metabolically healthy. The 3 precepts are protect the liver, feed the gut, support the brain. Any food that does those 3 is healthy by definition. Any food that does none of those 3 is poison by definition. And if they do 1 or 2, but not all 3, then they're going to be somewhere in between. Now, how can you do that? What is it that you actually have to do to the food? Number 1, get rid of the sugar. Number 2, add fiber. Number 3, add omega-3 fatty acids. And
that's where support the brain's coming.
Support the brain, and also the fiber too, because of the short chain fatty acids, both.
Okay.
And number 4, get rid of the emulsifiers. Now, the problem with processed food is it's all emulsified to hold fat and water together on a shelf. Well, those emulsifiers are detergents. They have a non-polar one end and a polar other end in order to basically keep the fat and the water together. Basically, they are detergents. They are the same stuff you put in your clothes washer. They are Tide. So what happens if you swallow Tide, emergency room physician? You burn a hole in your intestine is what you do. Well, in fact, that's exactly what's happening. We are seeing, we see the irritable bowel syndrome, the inflammatory bowel disease, the leaky gut. All related to these changes in intestinal inflammation driven by the components of ultra-processed food. So we have to undo that. The question is, can you? And the answer is, yeah, actually, you can. Now, you can't do it cheaply. You can't do it, indiscriminately. You can't do it not knowing what you're doing. But in fact, we have actually re-engineered 10% of the Kuwaiti Danish dairy portfolio to be metabolically healthy, and they are instituting those and putting those on the shelves in Kuwait today as we speak. And they are selling. And the reason they are selling, because we didn't tell the public.
Oh, really?
Really.
You gave the example of Coke management trying that. The reason it didn't sell for them was they told the public?
So it wasn't Coke. Coke never did this, but Pepsi did.
Oh, Pepsi, I'm sorry.
PepsiCo did it, right. So Indra Nooyi, the CEO of PepsiCo for about 14 years, she saw the diabetes pandemic, descend upon India. And India is not a obese country. They they have half the obesity we do, but they have 50% more diabetes than we do.
Huge diabetes.
Huge diabetes problem. And she became the CEO of the largest food conglomerate in the world, and she said, I'm going to do something to help my population in India. And so what she did was she developed what she called the good for you line. So they always had the fun for you line, which was the Pepsi and the Doritos, and she also had the better for you line, like the Slim Jims. So this was going to be the good for you line, like the hummus and the pretzels and the chia seeds and stuff like that. All right, the good for you line. Now, she wasn't going to change the goose that laid the golden eggs, but guess what? The goose stopped laying the golden eggs because she lost $349 million in 1 year, 2011. And Wall Street called for her head on a silver platter because she, quote, took her eye off the ball, unquote. Now,
so
she survived.
The mistake
that.
she made was she telegraphed this to the public and demand tanked.
Correct.
So she telegraphed it by labeling it good for you. And that's what Kuwaiti Dairy's not doing.
Exactly right.
Very interesting.
And it's working.
Well,
it's
that's,
amazing.
There is hope.
There is hope. I'm a pessimist by nature. Okay. And I've got hope.
Very interesting. You mentioned leaky gut a few minutes ago. When I've heard of leaky gut, it was a fellow named Alessio Fasano, a GI doc, had to do with heptoglobin, zonulin.
Zonulins. So zonulins are the famous tight junction, the one that goes defective in celiac disease. But there are other tight junction proteins as well. The thing that all tight junction proteins have in common is that they are ATP dependent. In other words, the cell has to generate the ATP to keep the zonulin functional, to keep the tight junction functional. So anytime an intestinal enterocyte becomes ATP depleted, anytime the ATP levels drop down, those tight junctions can become temporarily dysfunctional and allow stuff to pass across the intestinal brush border that wouldn't otherwise. So you can get transient intestinal permeability, transient leaky gut. So it's hard to find. It's hard to, anatomically, but physiologically and functionally, we know it happens because we can measure endotoxin in the bloodstream, of animals and humans after they've consumed, for instance, sugar.
So there are multiple mechanisms and offenders in terms of different types of leaky gut.
Exactly right.
Let's go back to fructose for a second. And this may be a question that you don't want to deal with, but do you think fructose is worse because of its metabolic issues or because of its addictive issues, or the combination, or what?
It's a combination of both. So the thing about fructose, that's, it's the sweet molecule in sugar. It does three things that glucose doesn't, okay? And all three are bad. The first thing that it does is it is a lipogenic substrate. That is, it drives more fat creation. And it does that because, number one, only the liver can metabolize fructose. So when you consume a fructose load, it all goes to the liver, which overwhelms the liver's capacity to be able to metabolize it, thus diverting more of the energy substrate to the fat pathway called de novo lipogenesis. And it also inhibits mitochondrial function by inhibiting 3 separate mitochondrial enzymes. Those 3 enzymes are AMP kinase, the fuel gauge on the liver cell, ACAD-L, acyl-CoA dehydrogenase long chain, and finally the third one, CPT1, carnitine palmitoyl transferase 1. Now, if you poison those 3 enzymes, you have defective mitochondria. And if you have defective mitochondria and you are overwhelming your cell with extra substrate, you're going to make fat. So fructose makes lots of fat, whereas glucose goes to glycogen. And glycogen is essentially non-toxic. Fructose does not go to glycogen. Fructose goes to fat. So that's problem number 1. We got 2 more to go. Problem number 2, the aging reaction, the Maillard reaction, the glycation/fructation reaction. So why do bananas brown? Well, the binding of a glucose molecule to a protein. So the caramelization reaction.
Glycation end products.
It's advanced glycation end products. Hemoglobin A1C is an advanced
Glycation end
product.
Right.
Okay. And the higher the hemoglobin A1C, the more that process occurred. Now, it occurs with glucose, but it occurs with fructose 7 times faster. So you make more AGEs with fructose than you do with glucose. Well, that is the aging reaction. That is what causes cataracts. That is what causes wrinkles. That is what causes endothelial dysfunction. That is what causes a host of metabolic perturbations in the body, which you can basically chalk up to the aging reaction. Fructose increases the rate of aging. This has been shown 50 ways from Sunday already.
First time I've connected the dots on AGE, advanced glycation end products, and it being so core to what we call aging on the macro level.
That's what it is. Okay. And then finally, number 3, you mentioned it before. Fructose stimulates the nucleus accumbens, the reward center of the brain. Glucose does not. So when you do look at the neuroimaging, and you can do it with PET scanning, you can do it with functional MRI, when you infuse glucose or when you ingest glucose, you light up the basal ganglia. Okay, you light up the substantia nigra, you light up the caudate, you light up thalamus, you light up a whole bunch of different areas of the brain. When you ingest fructose instead, or infuse fructose, you light up the reward center. Okay?
Mm-hmm.
And anything that lights up the reward center in extreme is addictive. So you can have chemical addictions like cocaine, nicotine, heroin, alcohol, sugar. They all light up the nucleus accumbens. You can have behavioral addictions such as shopping, gambling, internet gaming, social media, pornography, behavioral addictions. So not chemical addictions, but nonetheless, you light up the nucleus accumbens, you get addiction. Fructose lights up the nucleus accumbens. Glucose doesn't.
The first time I heard you call fructose a gateway drug, but the more I thought about it, the more you got me on it.
You know, if your audience is interested, you can go to YouTube and put in Eric Clapton, Ed Bradley, 60 Minutes.
I've seen that.
It is a 30-second clip from the late 1970s that Ed Bradley did with Eric Clapton, asking him how he got into addiction. And Ed Bradley says, heroin? And Eric Clapton says, no, sugar. 5, 6 years old, I was ramming sugar down my throat. Sweets, sugar on bread and butter. I became addicted to sugar because it changed the way I felt. Yes, fructose is a psychoactive substance. The thing is, people don't recognize that it's addicting because it's always there. You only know it's addicting when you can't find it.
When you lose your source.
Right. If it's on every street corner, how do you even know? I mean, how many people do you know say, oh, I have a horrible sweet tooth? That's sugar addiction until proven otherwise. So this is the problem. So there are 3 things that fructose does that glucose does not. And what fructose really does is it makes ROSs. And now we know that ROSs core of this unifying hypothesis of obesity, having nothing to do with calories per se.
ROSs are obesogens in and of themselves.
In and of themselves.
Which I never connected on until this discussion.
Well, this is why this is important. And I'm very happy, for your audience to understand this and know this.
Very much appreciated. So another favorite topic of yours, non-nutritive sweeteners. Are they more like methadone? You know, the analogy that I'm speaking of there.
Yep.
Methadone clinic, and maybe another addiction, but maybe not so bad. Or do they also actually drive insulin release and therefore create disease in and of themselves?
Right. So this is a very good question, and we're still working on the research for this. If you do a aspartame tolerance test, you don't see an insulin response. If you do a sucralose tolerance test, you don't see an insulin response. If you do a stevia tolerance test, you don't see an insulin response. So they are not driving insulin directly. However, if you team that aspartame or sucralose or stevia or monk fruit with other calories, you will get an accentuation of the insulin response because the artificial sweetener was there, even though it was an artificial sweetener and not sugar. You will get more insulin out. You will get 20% more insulin out just because non-nutritive sweetener was there. In addition, another group in Singapore did this great study, which I love. This is one of my favorite studies. Here's what they did. They took about 20 normal people and they admitted them to a clinical research unit 4 times, a week apart, in random order. And each time they were admitted for the whole day, here's what happened. In the morning when they got there, got an IV placed, and they underwent either a sucrose tolerance test or an aspartame tolerance test or a sucralose tolerance test or a monk fruit tolerance test. So 2 hours where they measured glucose and insulin immediately after receiving the sweetener, whether it was caloric or non-caloric. Okay. Then it was time for lunch. And they let these people have basically an unlimited lunch, whatever they wanted off a metabolic buffet. But everything that they consumed was cataloged and checked. And they also drew glucose and insulin with lunch, in response to the lunch. And they also kept them, and they did the same thing at dinner. So they had a metabolic buffet at dinner each time. And they, again, got the glucose and the insulin from dinner. So they had 12 hours of glucose and insulins. In the morning, during the tolerance tests, the sucrose made the glucose and insulin go up, as you'd expect, of course.
Right.
And the other 3 non-nutrient sweeteners did not. That is correct.
Didn't make the glucose or the insulin go up.
That's correct. But when they looked at lunch and then they looked at dinner, the days that they had the non-nutritive sweetener in the morning, those days for lunch and dinner, their glucose and insulin responses were higher than on the day of the sucrose tolerance test. And they ate more. And when they looked at the area under the curve of the glucose and the insulin for the whole day, turned out it didn't matter what day it was. They were all the same.
So meaning the non-nutritive sweeteners stimulated appetite.
It primed the beta cell.
It primed the beta cell as well as the appetite.
That's right. And so it ultimately didn't matter what they had which morning.
Got it.
This is very important because people argue all the time, if it's about calories, then non-nutritive sweeteners should, make a difference, but they don't. There are no studies which show that artificial sweeteners, substituting artificial sweeteners for sugar, actually promote weight loss. And this is probably why.
We went back and studied that Singapore study after seeing your mention in Huberman.
Yeah.
And so we were seeing that, no, they didn't really increase insulin, blood sugar, but it did equal out the whole day's appetite and insulin response.
That's right. For the whole 24 hours, it didn't matter what you had in the morning.
So the point of the study, and your point is, you take a non-nutritive sweetener, you're going to end up at the end of the day having consumed the same amount of sugar.
That's right. Having to consume the same number of calories too.
And driven the same amount of insulin.
Exactly right. So that's why non-nutritive sweeteners don't seem to be a very good answer. Plus, we now know that certain non-nutritive sweeteners, not all, but certain non-nutritive sweeteners actually change the microbiome and predispose to leaky gut. The point is, people want non-nutritive sweeteners to be the answer, and I'm not sure that they are.
I would agree with you. I don't think they're an answer. I think it sounds like, to get back to that methadone analogy, well, it's sort of like the methadone creates more appetite for the other narcotics during the rest of the day.
If you're using methadone as a temporizing measure to wean, then heroin, which is much more dangerous, then I can certainly understand why you would do that. But you have to then have an active protocol for weaning. So if you're going to use diet sweeteners as the wean for sugar, then you have to have an active protocol for weaning.
Right.
You can't,
because it's still addictive. Both of them. Methadone's still addictive.
Right.
Non-nutritive sweeteners are still addictive.
Right. Opioids are addictive no matter what.
So a personal question, you can obviously choose not to answer, but when we look at a pioneer in this space, a standard bearer, we say, okay, what does he do in terms of personal addictions? I've seen you mention, I think one time that you had an addiction to coffee.
Oh yeah, I'm a caffeine addict. And if you take my Starbucks away from me, I will kill you.
So this is Starbucks neat, no additives.
Pete's, you can be Pete's too. I mean, no
additives, no creams, no sugars.
Black coffee only. If you're a physician, and you are, okay, you know that you don't put anything in your coffee because you never can find anything to put in your coffee because you work in the hospital. You better learn to drink it black.
So no addictions on the food side, no carbs, no.
I love sugar the same as everybody. I love alcohol the same as everybody. But I also know I can put it down. Okay. So it's not like I'm somehow constituted differently from anyone else.
We touched on Munch a few minutes ago. We said we were going to get back to it. Here's the question. It's not so much about you and your role in it. It's the question of, okay, how practical. Yes. I mean, I think you've said, now I think most of us would agree, we're not going to create a theoretical world where processed foods don't exist and the demand for processed foods evaporate. So another way of dealing with this is a very practical, easy supply of fiber. How important is soluble fiber versus insoluble fiber?
They're both important. One's not more important than the other. They're equally important. They have to be together. And that's kind of the trick. And that's basically the genius behind this
Munch.
So let me tell you the story with the few minutes we have left. Very simple. I'm sitting in my office at UCSF in 2009, and this Italian engineer wanders in, wants to ask me a few questions. Never saw him before in my life. I'm a nice guy. He had some questions written down. I thought, well, it won't take me long to answer them. So I answered them. He went away. 2 years later, he calls me up on the phone, says, remember me? I said, oh, yeah, I remember you. I want to ask you some more questions. I'll take you to lunch, he said. I said, who's paying? I'm paying. We go to lunch. I answer some more questions. 2 years after that, he calls me up again, wants to take me to lunch. This time he's got a prototype of what he's been working on. He shows me at the sushi bar how this thing works. And, oh, wow, that's pretty cool. He goes away. 2 years after that, he shows up in my office again, this time with 6 patents, a job offer, and a CEO.
Interesting.
So I've been...
So you're involved in the primary idea.
In the inception of this from the beginning, right. So I am a co-founder of this company called Biolumin. And we have one product. It is called Munch. Now, I hate that name, but nonetheless, that's what the marketers came up with. We spent a lot of time trying to come up with a name, and they all sucked. And somehow Munch is the one that worked. So it's at munch.shop, MONCH.shop for all of your audience who want to look into it.
Wait, it just hasn't arrived.
All right. The company is biolumin.tech. Now, what is it? It is a microcellulose sponge, 7 microns in diameter, so it's the size of a red blood cell, pours like a powder. It is colorless, odorless, tasteless, and textureless. Your tongue can't tell it's there. You can put it into virtually any food. You can put it into ice cream, you can put it into yogurt, you can put it into bean dip, you can put it into chocolate, you can put it into breakfast cereal, you can put it into virtually any food that is not aqueous. Because if it was aqueous, it would start swelling. Okay, but other than that, you can put it in any food. You swallow it, it goes to your stomach, it starts expanding. It expands 70-fold over its original size, gives you a feeling of fullness. You only have to take 1 teaspoon. So 4 grams in a sachet, okay? Expands 70-fold over its original size. And when it expands, the nooks and the crannies in the sponge now become obvious. And impregnated, embedded in those nooks and crannies are a set of proprietary hydrogels, soluble fiber. So the cellulose is the insoluble fiber. The hydrogels are the soluble fiber, and they are embedded together in a matrix. And what those hydrogels do is they sequester, soak up unavailable glucose, fructose, sucrose, simple starches, rendering them unavailable for early absorption in the duodenum, thus reducing the glycemic excursion, keeping the insulin response down, thus protecting the liver, and moving the carbohydrate further down the intestine where the microbiome is so that the microbiome chews it up instead of you, thus feeding the gut. And in the process, generating short-chain fatty acids to support the brain. So you are protecting the liver, feeding the gut, supporting the brain because of this exogenous fiber, which takes the place of the fiber that the food industry took out. We are replacing what the industry took out. In other words, we're turning apple juice back into apples in the intestine. And it works, and we have clinical data, and most importantly, no side effects. And I got to tell you, I was shocked. No side effects. Nobody stopped taking it during our 2 clinical trials. In fact, it improved gut health. If they had diarrhea before the study started on Munch, they didn't. If they had constipation before the study started on Munch, they didn't. In fact, nobody discontinued using it over the 3 to 4 weeks of either study. It's really remarkable. And we saw improvements in blood pressure. We saw improvements in percent body fat, improvements in visceral fat, improvements in lean mass, and also improvements in craving, improvements in glucose area under the curve, insulin area under the curve. You know, we saw metabolic health and gut health improvements over a 3 to 4 week period with no side effects. Kind of cool.
I'm glad I ordered some. I'm excited to try it. I did a video once where I did a glucose tolerance test using Mott's applesauce that moms give to their kids. My blood sugar went over 200. Indeed. I'll have to try that with a little bit of Munch.
See what happens. Yep.
You know a little bit more about our audience, about me, and you clearly know your message. What did I miss? What question would you have asked if you were me that we didn't get to?
Well, we talked about sugar, we talked about fiber. You know, we didn't talk about sort of the other stuff. Remember the omega-3s, how important those are. You know, our diet sucks. And one of the reasons it sucks is because it's ultra processed. Well, omega-3s don't go in ultra processed food because omega-3s taste like fish.
Yeah.
You know? It's not something that the food industry, you know, has wanted to add. Well, we are doing that in the KDD paradigm. We are making sure that we add omega-3s because omega-3s are anti-inflammatory. They are anti-Alzheimer's. They are anti-depression. And, you know, our diet right now is omega-3 deficient. It is fiber deficient, it is omega-3 deficient, and it is fructose replete. Okay, those are the 3 things that have to get fixed. And then the emulsifiers are, you know, number 4. That's a little harder but we're doing that too.
And the public is still buying it. Demand continues, even though omega-3s, fish oil, krill oil have been added.
Yep, that's right.
Very exciting. There is hope after all, isn't there? When you look at our patients, over half of them come in and say, yep, I've had a weight problem. I've already lost 30 pounds or more. And we'll congratulate them. We'll say, well, great. How'd you do that? And they'll all but about half a dozen will say the same thing. Well, I started by dropping my carbs. My appetite decreased. And then most of them will say, yep, I did some form of intermittent fasting, which for most of them equals skipping breakfast. So
Right.
Our population realizes that we're not in a food desert. We're in a food swamp. We're up to our neck in killer types of food. So yeah, we want to support public policy pioneer like Robert Lustig, but we also want to make sure that we and our families live long enough to do that. A lot of this is going to be how do we protect ourselves from the food swamp that we live in. We looked at at your recent podcast with Andrew Huberman. You talked about the porterhouse steak example.
Let's say you eat too much protein. You have, the porterhouse steak. All right. Now, if you're a bodybuilder, those amino acids might go to muscle and you might increase your muscle mass because you're a bodybuilder, because you're putting excess force on those muscles and you're growing those muscles. Okay. But let's say you're not a bodybuilder. Let's say you're a mere mortal like me and you eat that porterhouse. You've taken on all these amino acids. There's no place to store it other than muscle. So your liver takes the excess and deamidates that amino acid, takes the amino group off to turn it from an amino acid into an organic acid. And then that organic acid can then enter the Krebs cycle, the tricarboxylic acid cycle, what goes on in the mitochondria in order to generate ATP, the chemical energy that your body needs in order to power itself. Okay, now that's a good thing. It takes double the amount of energy to prepare that amino acid for burning as it does to prepare a carbohydrate for burning.
That trips off a debate that you see in our community. As I mentioned before, we've got a lot of folks that have lost a lot of weight by cutting carbs. Then it brings up the question, okay, what do you replace some of those carb calories with? Do you replace it with fat? Do you replace it with protein? The porterhouse discussion you had with Huberman would indicate for that kind of person, you might go with more of a protein.
Or you might replace it with nothing.
Well, that's a good point as well. So wanted to open up to you to talk about anything from bomb calorimeters, a calorie is not a calorie, you're eating for 3 trillion or 100 trillion.
Something like that.
To proteins and any of that stuff.
It's funny, Dr. Brewer, that we should be having this podcast today. And the reason is because at 10 a.m. this morning Pacific time, a paper that I've been working on with colleagues for the last 2 years finally appeared this morning in the International Journal of Obesity, which I'm actually quite excited about. And the title of the article is Obesogens, a unifying hypothesis on the pathogenesis of obesity. Now, your audience probably doesn't know what an obesogen is. An obesogen is a chemical in the environment that drives adiposity exclusive of its calories. So there are things in our diet that drive adiposity that have calories. And so people think, well, then that can't be an obesogen. But if it drives increased adiposity over what the caloric content is, then it would be. There are chemicals in our environment that we're exposed to, for instance, air pollution, PFAS, DDT, BPA, phthalates, flame retardants, parabens. They don't have any calories, yet they drive adiposity in humans as well. Now, how can that be?
They make us fat.
The question is, if it's all about calories, and that's what virtually everyone thinks, because that's what the food industry has led us to believe over the last 100 years. If it's all about calories, how do you explain that? In addition, if it's all about calories, how do you explain why we have an epidemic of newborn obesity all around the world? If you do DEXA scans on babies born right out of the womb, they now weigh 200 grams more than they did 25 years ago. And when you look at the body composition on that DEXA scan, it's all fat. If it's about calories, if it's about calories in, calories out, if it's about gluttony and sloth, if it's about diet and exercise, I mean, how do you explain that newborns are being born obese? Well, because it's a little bit more complicated than that. And so this paper that I'm referring to actually delves into the four different models of obesity. One, the obvious, the energy balance model, the calories in, calories out model, which virtually everyone believes, perhaps you don't. Number two, the carbohydrate insulin model, which we started talking about, that the refined carbohydrate drives insulin release, and insulin release drives energy deposition into fat. And that makes a lot of sense, except that it doesn't explain the obese newborn, and it doesn't explain the epigenetics and the transgenerational inheritance. The third one, which people don't necessarily know about, is the redox model. Now, there are chemicals in every cell that are either oxidating or reducing. Now, they cancel each other out electrically, but whether or not you have increased oxidative substances can ultimately determine whether or not specific enzymes in the cell that are involved in the energy regulation pathway, for instance, AMP kinase, for instance, ptylanositol 3 kinase. These are all kinases. Every one of these energy forks in the road are kinases, which means that they can be phosphorylated. Well, the degree of redox potential inside the cell determines whether or not any given molecule is phosphorylated or not. And that can then direct adiposity in a different specific direction, having nothing to do with calories per se, but rather with electrical activity. And then finally, we have this fourth model, the obesogen model, the idea that chemicals can drive adiposity by binding to receptors and acting as what we call endocrine disruptors. It sounds like there are these four different models of obesity, and they would have nothing to do with each other. Well, in fact, that would be wrong. They have everything to do with each other. And the purpose of the paper is to explain how, in fact, each of the four, shall we say, sub-models actually contribute to an overlying unifying hypothesis that has to do with the chemistry of the cell and whether or not specific oxidative reactive oxygen species are driving adiposity. Now, it can be driving it in the liver by promoting insulin resistance. It can be driving it in the beta cell by promoting insulin release. It can be driving it in the brain by promoting increased food intake. It can even be driving it in the microbiome by altering cytokine expression. So what's interesting about it is all of the data on oxidative species all line up in the same direction, that if you increase reactive oxygen species, you get adiposity. And we know that reactive oxygen species are associated with adiposity. We didn't necessarily know they were a cause. So this is a very exciting paper because what it says is whichever model you subscribe to, you're right and you're wrong. It's not the whole
because
story.
it's bigger than that one
Because
model.
it's bigger than, exactly, it's bigger than the one model. That's the first thing it says. The second thing it says is that there are drivers of obesity and that they're all biochemical. Even the behaviors are biochemical. And that's really important because we have this, blame the victim concept in America. And this basically undoes the blame of the victim because it's all biochemical. And the last thing it says is that really the only way to deal with this is prevention. that we really have no method for dealing with this increased reactive oxygen species overload that drives the adiposity other than prevention. And that means that we really have to rely on public health paradigms rather than expecting people to be able to handle this themselves.
For those of us in the trenches dealing with prediabetes, diabetes every day, I listen to you and this redox model, the oxidation model, you hear so much about a pre-diabetic metabolism being so oxidative. I got stuck on that when you were describing these models.
Well, in fact, that's exactly right. I mean, basically, what these reactive oxygen species are doing is they're causing cellular dysfunction. Now, generating reactive oxygen species is part of cellular metabolism. The mitochondria, when they burn energy to carbon dioxide and ATP, okay, they release reactive oxygen species, but those reactive oxygen species are quenched. They are detoxified, and they are detoxified in a organelle in the cell right next to the mitochondria. Every mitochondria is right next to something called the peroxisome. And the peroxisome is where the antioxidants are. So mitochondria make the ROSs. The ROSs travel to the peroxisome, and inside the peroxisome, those reactive oxygen species are quenched, detoxified, so that they will not cause damage. So your antioxidant capacity has everything to do with your ability to withstand that ROS onslaught. What if you don't have the antioxidant capacity? What happens next? Well, those reactive oxygen species have not been quenched. They will travel to another organelle in the cell called the endoplasmic reticulum, and that's where proteins get made and folded. And if you don't fold your proteins right, they don't work right. Like, for instance, the insulin molecule, like the insulin receptor molecule. This is known as the unfolded protein response, also known as endoplasmic reticulum stress, which has been identified as being the primary driver of insulin deficiency in type 2 diabetes. So, in fact, the ROS pool in each cell is having negative detrimental effects on cellular function and energy utilization all at the same time. And we are seeing the manifestation of that every single day. So the thing to do is get the ROSs down. So that means you have to eat a certain way. And right now, the American diet is, shall we say, ROS-ogenic.
One other thing that occurs to me, when you talk about ROSs and our ability to quench those, have you gotten into MTHFR, methylene tetrahydrofolate, and genetic variations in that space?
So there is no question that MTHFR plays a role. So for your audience, that's methyl tetrahydrofolate reductase, which basically is necessary to regenerate folate in order to be able to methylate or demethylate certain proteins. The most important of those is homocysteine. You have to get rid of homocysteine. Homocysteine is a intermediate metabolite in the Krebs cycle. And if you make too much homocysteine, it lines your arteries and causes vascular smooth muscle proliferation and also endovascular inflammation, and is very correlated with heart disease. And you can have a genetic defect in this enzyme, MTHFR. And if so, then you really have to boost your folate intake in order to be able to mitigate that problem. So yes, MTHFR is related to this. Folate is related to this. B12 is related to this. And we know that if you don't have an appropriate supply of B vitamins, you end up with chronic degenerative disease, especially neurodegenerative disease.
Very good. Back to your point about being surrounded by ROS species or being filled up with them in our food supply. There again, as you said before, we can't expect people to overcome this one by one. On the other hand, as we talked about early on before the show, or what choice do a lot of us have? You know, a lot of us, any comments, thoughts about that area?
Got to fix the food. You know, I've dedicated my retirement, you know, I'm not seeing patients anymore. I've dedicated my retirement to fixing the food supply any way I can. Now, there are different pressure points and different pain points for different populations and different stakeholders at different times. So you can work at the molecular level in terms of the science, and you can work at the medical level in terms of the patient. You can work at the community level in terms of the availability of food, like for instance in schools. You can work at the public health level in terms of public awareness and public service campaigns. You can work at the food industry level in terms of changing the food. You can work at the federal level in terms of legislation. You can work at the environmental level and the planetary level in terms of climate change. All of these are related. Ultimately, this bad molecule that I've been spending most of my time researching over the last 20 years, fructose, the sweet molecule in sugar, which is a ROS driver like no other. It's, you know, basically ROS in a molecule. I mean, it is bad news. It generates 7 times the ROSs as does glucose. Okay, so this is one of the reasons why fructose is so problematic. You can go all the way from molecule to planet, understanding the pathophysiology of this molecule and explain basically everything from obesity to chronic disease to Medicare collapse to societal devolution and to climate change, all with this one molecule.
I've heard one of your presentations talking about fixing the Medicare finance problem, Social Security finance, all dealing with this one issue. And you know, it sounds like a joke until you actually start thinking about it.
Well, you know, there are a lot of arrows, and I recognize, you know, it's hard to keep all the arrows, you know, in one head at one time. But the fact of the matter is, this is a systems biology problem. These are not siloed issues. They all interact with each other, and understanding how they interact with each other is paramount in terms of being able to come up with effective solutions. And those solutions have to be brought to bear at different pressure and pain points in everyone's life cycle and also in the societal ecosystem. And, you know, somebody's got to put it together.